Hello, IB Bio student. All right, so today we are going to cover the last part of 9.1, which is plant experiments, and then looking at different ways that we can set up a transpiration experiment. So the first thing we want to start with is the application, and this is very simple. So looking at models of water transport in xylem using three different apparatuses: the filter paper, the porous pots, and the capillary tubing. So how would these three apparatuses, how would they model what plants do, which is transport water in the xylem from the root up to the shoot? Okay, and this is very simple. You've probably done some of these already. So this is what capillary tubing looks like. So you have a small, narrow capillary tube that is going to move water up. This is a filter paper that you've probably done this with chromatography. You see how the filter paper absorbs the water and water moves up. And here you have a porous pot, which is this guy up here, and you attach it to a sealed tube. And through negative pressure, you see how water starts moving up into the porous pot, and then that water gets lost through what resembles transpiration. So just, make sure that you know the details of how it works, and that the reason that this water is able to move up through these three models is because water has cohesive forces and water has adhesive forces. If you're undergoing a capillary tubing experiment, if your capillary tube is a thin one versus a thick one, obviously remember that the thin capillary tube is going to be able to move water up to a higher level. Okay? So the rest of this section talks about measurement of transpiration using pitometers. And a pitometer can be any device that you set up that is used to estimate transpiration rate. And this is measured by taking the rate of water loss over a certain amount of time. So it's usually, depending on what you're using to measure the water loss, it could be centimeters square per minute, which is a typical way to measure transpiration rate. So pretty much what you're going to do is you're going to attach, this is a pitometer here, you're going to attach a plant to this device, which we call a pitometer, and you're going to measure how much water is lost to transpiration, and you're going to measure that many ways. So in this particular pitometer, you devise a way to measure how an air bubble is moving along. So here you have a particular measurement, and as the plant is drawing up the water, then the air bubble is moving right along, and this movement here signifies, this movement in centimeters is going to signify how much water is being lost per minute. We don't usually use pitometer devices like this that we measure an actual air bubble, just because it's so hard to get that air bubble in there. And it's also very hard to make this an airtight pitometer. You have to introduce a cut stem, and you have to introduce it in a way that it's airtight, because you don't want the water, of course, evaporating via anything other than just transpiration from the leaves. So the models that we use in the classroom, or the pitometer that we use in the classroom, looks more like this. So let me show you. Like this one. It's called the burette and tube pitometer. And what we do is we set it up with a stand and a clamp, and then we use a flask stopper here that has a hole in it, and we seal the stem of this plant to a tubing. So the stem of the plant and the tubing have to be about the same diameter. We seal it with Vaseline to avoid evaporation of water. And then we have these clamps where on one side we're going to have the plant, and then on the other side what we're going to have is a graduated pipette. So underwater in a bowl or in a sink, you're going to do all of this connection, which is hard in and of itself. So you're going to connect the branch to one end of the tube, and you're going to connect the 1 milliliter graduated pipette to the other end of the tube. And you're going to allow water to come in, and all the tubing needs to be filled in with water. No bubbles, no gaps. And then the whole pipette, up to a certain point, needs to be filled with water. So let's say that our pipette is filled with water up to here. And let me get my marker here. And let's say that here, and again, this is in 1 milliliter, right? So this is from 0 to 1 milliliter. So if this is the 0.5 mark, right? As this plant is taken in water and the water is transpiring, right? Is leaving through transpiration, the water level here is going to dip down. And any change here in the pipette from 0.5 milliliters to 0.4, 0.3, 0.2, that's the amount of water that has left the plant through transpiration over time. And this takes a long time. So usually when we set up these transpiration experiments, we need to set them up overnight, sometimes 2 nights. Now notice that there's different ways to set up pitometers. So we have a filter paper pitometer. The traditional lab pitometer looks like this, but then you have to buy these setups here, and they're a little bit, of course, they're a lot more expensive than the setup that we use in class that looks like this. And then you have other ways to design pitometers, but they're not as accurate because, again, it's not a really accurate way to measure how much water is being lost here. So you just have to understand how a pitometer is set up, right? And the burette and tube pitometer works for me. And then you have to design an experiment to test the hypothesis, a hypothesis about the effect of temperature or humidity, or light intensity or wind exposure. So what I would usually do in the classroom is I would have each group set up their own pitometer, and then I would assign different independent variables to each group. So I would assign one group the independent variable of temperature, and perhaps I would either lower the temperature or higher the temperature for that particular group. Now keep in mind that increasing the temperature is predicted to cause an increase in the rate of transpiration. And then for another group, I would assign the variable of humidity, so then we have to keep the humidity high within that particular pitometer. And the way that we end up doing that is by putting a bag over the plant and then misting the plant over and over again with a water bottle. So we mist it all throughout the day, and the only time we can't mist it is when we go home. But then when we come back in the morning, we mist it again. So we keep a high level of humidity in there, and we try to see how that affects the rate of transpiration. Increasing the humidity is predicted to cause a decrease in the rate of transpiration. And then for another group, I would assign the independent variable of light intensity. So I would either do an increased amount of light intensity or a decreased amount of light intensity to measure the rate of transpiration. And finally, for the last group, I would do wind exposure. So then I would increase the level of wind exposure, which is expected to increase the rate of transpiration. So then what we would do would be we would place a fan in front of our plant, and then we would see how that affects the rate of transpiration. So the experiment works quite well. And then you're able to measure the rate of transpiration, and then you graph it and you show the relationship of all three variables, and that's it.